What is the temperature change occurring when 100 cubic centimeters of 1 moles per DMQ sodium hydroxide solution were mixed with 100 cubic centimeter of HCl solution of the same concentration in a thermally insulated container. The standard enthalpy of neutralization is given, the specific heat capacity of the solution is given, and the density of the solution also given. What is the temperature change occurring when 100 cubic centimeters of 1 mole per dm cube sodium hydroxide solution is mixed with the 100 cubic centimeters of HCl solution with the same concentration? First of all, here we need to know what will happen in this case. Standard enthalpy of neutralization. Standard enthalpy of neutralization is the formation of 1 mole of water from aqueous H plus ion and aqueous OH minus ions. This is the neutralization. Formation of 1 mole of water from aqueous H plus ions and aqueous OH minus ions. For this reaction, it is given the standard enthalpy change. If you form 1 mole of water, then the enthalpy change is 57 kilojoules per mole. Per mole means if you produce 1 mole, the amount is this much. Here, sodium hydroxide gives us the OH minus ion, H plus gives us the HCl gives us the H plus. So this is related to the HCl. This is the NaOH. How we can get it? Because the HCl, once it dissolved in water, it will break into constituent ions like H plus HCl minus. Sodium hydroxide also sodium plus OH and OH minus ions. Therefore, that's good, right? Therefore, we can take the concentration of HCl and the number of moles using its volume. We can calculate the number of moles of HCl is 1 moles per dm cube. 1 into 100 into 10 to the power minus 3, that is 0.1. Here it is straight away that 1 into 0.1. That is 0.1 moles of H plus will react with 0.1 mole of OH minus. Then the 0.1 moles of water will be produced. Then the heat related to that one will be 57 into 0.1. Then it will be 5.7 kilojoules per mole or 5,700 joules. In this case, no need to put per moles. Actually, this is not per mole. It is just for 0.1 mole. So this is the amount of heat liberated when this reaction is taking place. That is the Q, the heat. Then we know that Q equals mc theta. Theta is the temperature change. M is the mass of the solution. So if you know the D is M over V, then M equal dV. Now the volume is 200 cubic centimeters because 100 cubic centimeter of each. So now I can substitute this M with dV. So dVc theta is the Q. But I need the temperature change, that is theta. Theta is equal to Q over dVc. Q is equal to 5,700 joules. Density is 1 grams per cubic centimeter. The volume is 200 cubic centimeters into the C. C is given as 4.2 joule per gram per Kelvin. In this case, Puta, instead of that Kelvin, you can put the Celsius also. We'll let you know later why it is per Celsius, because answer is given in Celsius, so that's why I put this Celsius. Then per gram and gram will cancel, cubic centimeter will cancel, then joule and joule will cancel, per Celsius will go to the numerator as Celsius. So here 2 zeros will cancel. Now your answer is 57, sorry, 57 divided by 2 into 4.2 Celsius. So you can go to log table and do the calculation, but here I don't use that. I can straight away use something else, means that my calculator, 57 divided by 2 into 4.2. Yeah, answer is 6.78. 6.78. Let's see whether we have such answer. It is 4. 6.78 is nearly equal to 6.8. So answer is 6.78 Celsius. Answer is 4. And the other important thing you need to know, say you have something like this. Celsius 0, Celsius temperature, 27 degree temperature, 100 degree temperature, say. If you get the difference in Celsius, in between these two, the difference is 27. In between these two, it is 73 Celsius. That is the difference. I can express the same in Kelvin. 0 Celsius means 273 Kelvin. 27 means 300 Kelvin. And 100 means 373 Kelvin. If you get the difference here, again difference is 300 minus 273 is 27 Kelvin. If you get this difference, again it is 73 Kelvin. Means when we get the difference, temperature difference, you can express that in Celsius or Kelvin, because the scale is same. Scale means 1 Celsius is equal to 1 Kelvin. That means in this scale, the difference between 2 points is 1 Kelvin, no 1 Celsius. In the development of this scale, they have taken 0 and 100, and that has been divided into 100 tiny particles or small. They have divided that into 100 parts. So in the Kelvin scale, the difference may be same. 0 is 273, this is 373. Again, same number of divisions available here. So you get that. A buffer solution of pH is pH 4 is formed when 50 cubic centimeters of 0.2 weak monobasic acid. I will take it as HA. Yes, they have taken as HA. HA mixed with 50 cubic centimeter solution. It's sodium salt. If Ka of this HA at the relevant temperature is 1 in 10 power minus 6, what is concentration of Na solution mixed? Normally remember that if you have the acid, weak acid, and its conjugate base A minus. Such, if you find such mixture, normally we add the Henderson equation. As this is an acid, we can write down the Henderson equation. And the other thing is, remember that NaA, because of the presence of NaA in high concentration, normally dissociation of this HA will be very small and negligible. By assuming that, we can write that A minus concentration is equal to NaA concentration and HA is given. So that is what we assume in this calculation. Whenever you find acid and conjugate base or base and conjugate acid, normally we use that Henderson equation. For an acid, the Henderson equation is pH equals pKa plus log A minus concentration over HA concentration with physical states. Now you are asked to find this A minus concentration. Then pKa minus log 10 to the power minus 6 plus log A minus concentration. Because this is a division, I can write down minus log HA concentration. Here the HA concentration has to be calculated here. Why? The volume and concentration given, but we add in some aqueous solution into there. That means you have to get the new concentration. New concentration once mixed. HA concentration once mixed is equal to 0.2 moles per dm cube into 0.05 decimeter cube. That is the 50 cubic centimeter. Divide by now the total volume 50 plus 50, 100 means 0.1 decimeter cube. So decimeter cube will cancel. So it is 0.1 moles per dm cube. That is the new concentration. So it is HA concentration 0.1 equals 10 to the power minus 1. So it is 0.1. Now pH equals 4. pK is equal to here 6. Anyway, this one is 6. Minus 6 into minus 1, 6. Plus log A, we don't know that. Log A, that is what we need to calculate. And here, 10 to the power minus 1 into minus 1 can be plus 1. එතකොට අපිට එනවා log A equals log A minus concentration is equal to 3. එහෙනම් A minus concentration is 10 to the power minus 3 or 0.001 mole per dm cube. So this is the answer. Then it is 10 to the power minus 3 moles per dm cube. 1 into 10 to the power minus 3. Your answer is first one. In this case, you will get the concentration. This is not, the answer is not the first one, right? Why the answer is not first one? Because in this case, you get the concentration of A minus after mixing. The volume has been doubled. Therefore, the initial A minus concentration may be something else. Right? So, this is the concentration after dilution. Dilution is concentration has been halved. Therefore, the A minus concentration in original solution equals 2 into A minus concentration in mixed solution. By mixed solution के concentration we calculated that, but the original solution we have double the concentration, so it is 2 into 10 to the power minus 3 moles per dm cube. This must be the correct answer for this. The second one. Which mixture of the following compound is given by the reaction between the compound these two? Remember that this compound is an ester. Ester contains this group. When we add sodium hydroxide into an ester, it will break through this and give us the carboxylic acid and alcohol. This is what first happens. What happens? We have Cl, CH2, CH2, O, O benzene ring, and Cl here. When we add sodium hydroxide, it will first give, I will just consider the dissociation of these. Later, I will consider the others. Here, what really happens? CH2, CH2, CO, OH will be formed, but we have, this is the acid, as we have sodium hydroxide, this will react with base, gives us the sodium salt. And we know that the other thing is we have here Cl. Aliphatic Cl will be replaced by OH minus when it is treated with a strong base like sodium hydroxide. So this becomes OH. And when we get the other side, you will get the alcohol. Alcohol in this case, the alcohol is our phenol. So you will get the phenol. And again, phenol will react with sodium hydroxide, giving the sodium phenate. So this becomes again plus and minus. And remember that the directly attached halide to the benzene ring cannot be replaced or cannot be substituted by OH minus group, because this Cl minus or any halogen may have lone pairs. That lone pairs will be interact with the 5-electron cloud. Therefore, this may have some sort of double bond nature. Therefore, it is very hard to break through. So, your final product may have sorry, this mixture only. So your answer must be, this has to be converted to OH and this is the salt of that. So here it cannot be first one, all the others can be straight away. The answer is second one. OH, ONA, ONA, Cl. Yeah, here the position of the place of Cl is not correct, but it doesn't matter where it is. So this is the correct answer. Answer is second one. A is a colored inorganic salt insoluble in water. When a few drops of solid A is dissolved, when a few of the solid A is dissolved in excess of hydrochloric acid, colorless gas G is liberated, giving yellow solution. When Q is diluted with water, first it turns green and finally blue. The gas G, when passed into bromine water, turns bromine water colorless, giving the solution T. On addition of barium chloride solution, T gives a white precipitate P, which is insoluble in nitric acid. Which of the following could be A? Okay. Inorganic salt insoluble in water. First, we need to identify which are not soluble in water. CuBr2 dissolved in water. Copper carbonate, I don't have idea. I think it is not. Normally, copper carbonate is a precipitate. Nickel sulfide, copper sulfide. Copper sulfate is definitely soluble in water. These three may be precipitated. Hydrochloric acid is added. When we add hydrochloric acid into each of these, say we add in an acid to each of these, this will liberate CO2, this will liberate SO2, and this will liberate SO2. Why? Any carbonate, any sulfide will liberate colorless gases, gas, when we treated with an acid. If you had S2 minus ions in this case, then S2 minus will liberate H2S. Right. Then colorless gas is liberating. That's okay. And the yellow solution. Normally, when nickel dissolves, nickel may give us yellow solution because we add in hydrochloric acid in excess. Excess of hydrochloric acid will give us, when we add, say, HCl, we add in, then copper will give us CuCl. 4,2 minus, yellow in color. Here, nickel will produce the same, and this copper also Cu, and Cl4, 2 minus will be produced. And yellow solution, all are yellow solutions, right? All are yellow in color. And it says when Q is diluted with water, first turns green and finally the blue. Such is observation is given only by the copper. 2 minus, when we add water into this or dilute, first it turn into green because of this. This is green in color. And when we further add water, it will give us CuH2O, say 6 times AQ2 plus, this is blue in color, sky blue or pale blue. So it must be copper containing compound, not nickel containing compound. Nickel doesn't give such observation. Next, Q diluted green and finally blue. Because if nickel gives us only the green color solution now. This NiH2O 6 times 2 plus this is green in color. It doesn't turn into blue. This is green. That's why answer is copper containing compound. Then this third one cannot be because of that nickel. Nickel gives green. Then you can get the answer as 2O4. Next one, the gas G will pass into bromine water. Yeah, bromine water will be decolorized only by the sulfur SO2. See, SO2 plus Br2 plus water will give us H2SO4 plus HBr. So the bromine water, normally the color of that bromine water is yellow, see, orange colored solution, and HBr is colorless. So this observation is given only by this SO2. Therefore, your answer must be the fourth one, not the copper carbonate. Copper carbonate normally doesn't react with Br2. Actually, that CO2 will not react with Br2. That's why your answer is copper sulfide. The following pair of ion that cannot be distinguished by passing H2S. බලමු අපි zinc and nickel ammonical medium is in basic medium. If you pass H2S to indicate that medium is basic, I put OH minus, then it will give us a higher concentration of S2 minus ion. So zinc will give us ZNS white color. Nickel will give us NIS black color. This is black. This is white. If it is in two different containers, then you can distinguish them. If it is in a mixture, then you will not observe that white because of this black. So if it is in the mixer, you can't say that it is available in that mixer because of you don't get different colors. But if it is in two different containers, then you can. Then say next one, magnesium and cadmium. Magnesium, cadmium. Normally remember that when we pass H2S to magnesium hydroxide, sorry, this H2S in basic medium, normally this magnesium gives us magnesium hydroxide precipitate. How it happens? It first say it may be formed that magnesium sulfide, but it is hydrolyzing because it is unstable, giving magnesium hydroxide and H2S back. So straight away you can write down magnesium hydroxide is the product. If you get the cadmium, it forms cadmium sulfide. Cadmium sulfide is given in the second group of group analysis. So it is yellow. Magnesium is gelatinous white precipitate. This is a yellow precipitate. So we can distinguish them because of the color. The copper and bismuth. Copper and bismuth both will give us a black color precipitate. Remember that S2 minus A, we add in H2S, means H2 minus. So it will give us copper sulfide and Pi2S3, both are black. So cannot be distinguished. Next one, chromium metal, cobalt, chromium 3 plus. It also same as that magnesium. When we add S2 minus, sometimes it will form Cr2S3, but it is unstable, so it will hydrolyze giving CrO. It's thrice precipitate, that is green colored precipitate, or green color white. Gelatinous precipitate, green. It doesn't give actually Cr2S3. Instead of that, it gives only the CrOH thrice. Even aluminium will be the same. If you have aluminium 3 plus ion, if you pass H2S through that solution, you will get aluminium hydroxide like this. Next one is cobalt. Cobalt 2 plus, when we plus S2 minus, it will give us black. However, it can be distinguished. Zinc and cobalt, again zinc white, cobalt black, so can be distinguished, but this cannot be. Copper and bismuth cannot be distinguished because both of them will give the same black color.